anyway, I'll repeat my introduction. Good afternoon, everyone. I, Shanti, an assistant professor in Department of Physics, on behalf of Institute of Science, Banaras University, welcome you all to the second Dr. Shanti Swarup Bhatnagar Memorial Lecture. To mark the lecture today amongst us, we have distinguished guest Dr. Anjan Ray, Director, CSR, Indian Institute of Petroleum, Dehradun. In addition, we will also be having with us the DG CSR, Dr. N. Kalai Selvi, who shall be joining us in a short while, but in an online mode. Dr. Shanti Swarup Bhatnagar was born on 21st February, that is today, 1894. He was the founder director of Councils of Scientific and Industrial Research, today we call it often as CSR. Dr. Bhatnagar played a significant role in building up post-independent science and technology infrastructure and also in the formulation of science and technology policies of India. He was also the Secretary of Ministry of Education. Eventually, he was also the first chairman of University Grants Commission, educational advisor of the government, as well as many more that we can account for today. With this, I would like to request our distinguished guest, Professor Dr. Ray, Professor A.K. Tripathi, Director, Institute of Science, as well as Professor Madhulika Agrawal, Dean, Faculty of Science, to kindly offer floral tribute to Mahamanaji as well as Dr. Bhatnagar. Thank you, ma'am. May I now request you to please come on the dais and take your distinguished seats, please. Thank you, sir. Thank you, ma'am. In order to begin the program, I would also request our director, Professor A.K. Tripathi, to kindly offer the bouquet to welcome Professor Ray. Thank you, sir. Thank you, ma'am. Many of us perhaps don't know that besides being an eminent scientist, Professor Bhatnagar was also a Hindi poet of repute, and that during his stay in Banaras University, he composed the Kulgeet of the university. Professor Bhatnagar is remembered with reverence in this university and will be continued to do so till the university exists. As a customary of this institution, we begin the event with the Kulgeet of Banaras University, for which I request our students to please come forward for it. I also request our students who are sitting here in an audience, please do not clap after the Kulgeet.
सुंदर यह सर्व विद्या की राजधानी राजधानी मधुर मनोहर अतीव सुंदर यह सर्व विद्या की राजधानी राजधानी ये तीनों लोकों से न्यारी काशी सुज्ञान धर्म और सत्य राशि बसी है गंगा के रम्य तट पर यह सर्व विद्या की राजधानी राजधानी नए नहीं है ईंट पत्थर है विश्वकर्मा का कार्य सुंदर रचे है विद्या के भव्य मंदिर यह सर्व सृष्टि की राजधानी राजधानी यहाँ की है यह पवित्र शिक्षा कि सत्य पहले फिर आत्मरक्षा बिके हरिश्चंद्र थे यहीं पर ये सत्य शिक्षा की राजधानी राजधानी पवित्र ईश्वर की सत्य वाणी बने जिन्हें पढ़ के ब्रह्म ज्ञानी थे व्यास जी ने रचे यहीं पर ये ब्रह्म विद्या की राजधानी राजधानी वह मुक्ति पद को दिलाने वाले सुधर्म पथ पर चलाने वाले यहीं फले फूले बुद्ध शंकर हे राज ऋषियों की राजधानी राजधानी सुरम्य धाराएं वरुण हंसी नहाए जिनमें कबीर तुलसी भला हो कविता का क्यों न आकर ये वाग विद्या की राजधानी राजधानी विविध कला अर्थशास्त्र गायन गणित खनिज औषधि रसायन प्रतीचि प्राची का मेल सुंदर ये विश्वविद्या की राजधानी राजधानी ये मानवीय जी की देशभक्ति ये उनका साहस ये उनकी शक्ति ये मानवीय जी की देशभक्ति ये उनका साहस ये उनकी शक्ति प्रकट हुई है नवीन होकर ये कर्म वीरों की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्व विद्या की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्व विद्या की राजधानी राजधानी
Thank you so much, Debarita, Shashank, Siddharth, Dakshita, and Abhinandan, all of them the students of Institute of Science. Nothing can be more assuring and heartwarming than the affectionate words of welcome. To formally welcome us up here, may I now request Professor Madhulika Agarwal, Dean, Faculty of Science, to kindly deliver the welcome address. Thanks, Archana. A very good afternoon all. Dr. Anjan Ray, the speaker of the second Professor S.S. Bhatnagar Memorial Lecture Award, our beloved director, Professor A.K. Tripathi, distinguished professors, head of the departments, colleagues, researchers, and dear students. It is a proud privilege for me as a Dean, Faculty of Science, and on my own behalf to welcome you all in this hall for the Memorial Lecture Award. We have just heard a Kulgeet as said by Archana that Professor S.S. Bhatnagar was a poet also. So beautifully he has written it, this Kulgeet. All over the world, the BHU alumni connect themselves with this Kulgeet. Can you imagine? Whenever our foundation day comes, we get hundreds of WhatsApp messages with this Kulgeet only. Professor Bhatnagar was here just for 3 years. And during the very formative years of this university, he joined in 1921 and he was here for 3 years. So during that time itself, he has thought of the inspiration of this university, the dream of Mahamanaji, and the future of this university. It's really remarkable. So, Professor Bhatnagar was not only a very well-known scientist, not only a policy maker, not only an administrator, but have a heart full of emotions. And that is how he would write this Kulgeet. So with this start, I am so happy that today with us, Dr. Ray is here. I welcome you on my own behalf and on behalf of Institute of Science. And I am very thankful to you for your presence over here and your acceptance of delivering a talk on such a apt title of preserving the planet or the Mother Earth. For your information only, because most of the listeners are our own people, we have almost in this Institute of Science 13 departments, 2 interdisciplinary centers, 3 schools. We have about 6,000 students here, out of them about more than 1,000 PhD scholars, 2,500 master students, and similarly 2,500 bachelor students. So in fact it is bigger than many universities. There are many central universities which are coming up, and it is bigger than that. Very recently I was attending a meeting of UGC chairman, and then when my turn came, I said we are so diverse. What do you expect from us to do certain thing related to NEP within a year or within 6 months? And he agreed on that. So we feel very proud to be so diverse, not only in our own faculty but throughout this university. I will not take more time because everybody wants to listen to you. So I also welcome Madam Dr. Mrs. N. Kalwa Selvi, Director General CSIR, who would be joining us
very soon, because she's there with the NITI Aayog meeting. So soon as she will get time, she will come over there. I forget to welcome my director. So I welcome you also here, and whomsoever has come late, I welcome them, and I'm stopping here itself. I wish all of you will gain more knowledge regarding a particular sector which is said to be most polluting. So the person who is going to talk today on a topic that how science and technology is struggling to preserve the planet. Thank you very much.
Thank you so much, ma'am. That is indeed informative about how our institute is apparently flourishing. Dr. Bhatnagar's research contribution in the area of magnetochemistry and physical chemistry of emulsion are widely recognized and highly acclaimed. Dr. Bhatnagar was also elected Fellow of Royal Society, London, in 1943 and later was been awarded Padma Vibhushan in 1954 by President of India. So moving right along in this path and also to know more about Professor Bhatnagar, may I now request the head Department of Chemistry, Professor Maya Singh, to please introduce the eminence of Dr. Bhatnagar to the gathering.
Distinguished speaker of today's program, Dr. Director, CSIR, IIT Bhatnagar, our highly dynamic, visionary, and much motivating to all of us, Director Professor A.K. Tripathi, and Dean Professor Madhulika Agrawal, my senior colleagues, heads of the department, my colleagues of this Institute of Science, and my dear friends and students. Really, I feel my immense pleasure to be a part of this program and telling something about a very brief note regarding Shanti Swarup Bhatnagar. Shanti Swarup Bhatnagar was born on 21st February 1894 at Bera in the district of Sahpur in Punjab. He was only 8 months old when his father died, leaving the family in dire poverty. Shanti Swarup was brought up by his maternal grandfather, who was an engineer by profession, and developed his interest in pure and applied sciences growing up with him. Shanti Swarup tasted an irresistible desire to dabble in Urdu poetry came as inheritance from his mother's side. Not only he had an extraordinary command on Hindi, English and Urdu literature, but also he was a natural poet, writing spontaneous poetry in Urdu as well as in Hindi. Most importantly, he wrote the BHU anthem, just we heard from the earlier speakers, Madhur Manohar Ativa Sundar Yah Sarv Vidya Kira, which is highly inspiring and soul-touching pulki. Its music was composed by Pandit Omkarnath Thakur, a great educationist, musicologist and classical singer. My dear friends, Professor Bhatnagar completed his BSc in 1916 with honors in physics at the age of 22, followed by MSc in chemistry in 1919 from Dayal Singh College at the age of 25. Presumably, the system of education in those days provided the for America via England in 1919. However, the breaking of the First World War prevented him going to America, so he decided to stay in England and join the University College London under the mentorship of F.G. Donnan FRS, a distinguished physical chemist. After earning a DSc in 1921, you see, he earned his BSc at the age of 22, MSc at the age of 25, but he earned his PhD degree within 2 years. After earning his PhD in 1921, he came back to India and appointed professor of chemistry at the just established Banaras University and worked there for 3 years till 1924, creating an active school of physico-chemical research. In 1924, he moved to Punjab University, Lahore, as a director of the University Chemical Laboratory, where he stayed till 1940, almost more than 15 years. That was his Karmabhumi. Dr. Shanti Swarup Bhatnagar holds a unique position in the annals of Indian science. He was a man of many dimensions, an outstanding scientist, an able science manager, an eloquent speaker, an effective communicator, a talented poet, a visionary creator of the institutions, and above all, a leader of men. Bhatnagar in his eventful 60 years achieved more than what generations of men could not accomplish. He left his indelible imprint on pure and applied sciences, demonstrating that science becomes relevant to society only when the practitioners are willing to descend down from their ivory towers and translate science into applications. A deep shadow fell on Bhatnagar's full and active life when his wife died in 1946. In her memory, he wrote a number of numerous diverse poems in Urdu and Hindi, and they are incorporated in his poetical connection named after her as Lajvanti. The celebration of his 60th birthday in February 1954 was held with a great deal of popular enthusiasm, and high tributes were paid to him by then Prime Minister Pandit Jawaharlal Nehru, Sir Charles Darwin, Alfred Egerton, Dr. Homi J. Bhabha, and many other distinguished great figures. After an evening meeting with the scientists, he returned home to bed at Baroda. He was staying that time at Baroda, and all of a sudden suffered a severe heart attack and passed away silently on 1st January 1955 at Baroda. He had by that time laid the foundation and erected the structure for the rapid growth of science in India. Besides holding several high positions and offices, many honors came to his way, the significant being OBE in 1936. OBE is the second highest ranking order of the British Empire award. Title of knighthood in 1941. After that, he became Sir S.S. Bhatnagar. Fellowship of the Royal Society in 1943. Foundation Fellow of the Indian National Science Academy. and several high significant honorary degree from a large number of Indian and foreign universities he received. His efforts led to the establishment of CSIR in 1942. In 1943, CSIR-GB approved a proposal to establish 5 national laboratories, that's NCL, NPL, FRS, CGCRI and NMI. In recognition of his outstanding contribution to Indian science and technology in India, CSIR instituted the most prestigious award of the country after his name, that is the Dr. S.S. Bhatnagar Prize, given to the Indian scientists for their outstanding contribution in the country. The government of India also finally honored him with Padma Bhushan in 1954. So with this very brief remark about Professor S.S. Bhatnagar, and thank you very much.
Thank you so much, sir. This is very enlightening to know about the life as well as how the things have evolved for Dr. Bhatnagar. Very inspiring indeed. Thank you. May I now request Professor Sateen Saha, because we have now a small documentary on the life of Professor Bhatnagar, which we would like to present up here, please.
Can say that he stood up to his name, Shanti Swarup, meaning embodiment of peace. He was born on 21st February 1894 in Beira, Punjab region of British India in a Hindu Kayastha family. Under the influence of his grandfather, he developed a taste for engineering and science at an early age. As early as 1911, young Bhatnagar published a paper on a method of making substitute carbon electrodes for a battery by heating molasses and carbonaceous matter under pressure. Besides his keen interest in science, he was proficient in Urdu grammar and wrote the play Karamati, for which he was awarded by the Saraswati State Society. He traveled widely in Europe and visited a number of institutions famous for research work in physical chemistry.
In August 1921, Professor Bhatnagar was appointed Professor of Chemistry in the Banaras Hindu University, and he worked there for 3 years, creating an active school of physico-chemical research. On the basis of his excellent research work done at London and Banaras, Professor Bhatnagar was selected for the post of Director of University Chemical Laboratories, Lahore. He was elected Dean University Instruction of the Punjab University. The 16 years from 1924 to 1940 as professor in the Punjab University was the most active period of his life for original scientific work. Professor Bhatnagar also offered 50% of all income out of patents to the university to be mainly devoted to scientific research work. Dr. Bhatnagar founded the Honors School in Chemistry in the University of the Undivided Punjab at Lahore in 1925. Under his inspiring leadership, the university attained high standards of teaching and research in chemistry, and several scholars received PhD and DSc degrees. In 1942, he developed in the Department of Scientific and Industrial Research Laboratories, a process for carbon electrodes to meet the shortage of imports during the Second World War. During this time, the Government of India established the Board of Scientific and Industrial Research and commandeered the services of Dr. Bhatnagar as director. The Department of Physics was started after the partition in Delhi in October 1947 under the supervision of Dr. D.S. Kothari, and Professor P.K. Kichlu took over as the head of the department.
He was a professor in chemistry for over 19 years and 169 scientific publications and 28 patents. He was the first Director General of CSIR. He was the first chairman of the University Grants Commission. In his memory, CSIR instituted the award Shanti Swarup Bhatnagar Prize for Science and Technology from 1958 to honor outstanding scientists. He played an instrumental role in the establishment of National Research Development Corporation of India. Before his death, 12 of these laboratories were fully functional, and as a result of the impetus given to the program by him, more than an equal number of new ones have come into existence. He was knighted in 1941 in recognition of his work for the war effort. In 1943, the Society of Chemical Industry London elected him an honorary member and later vice president. He was rewarded with the rare distinction of honorary membership of the Society of Chemical Industry. He was also elected Fellow of Royal Society London in 1943. He was the president of Indian Chemical Society, National Institute of Sciences of India, and the Indian National Science Congress. He was awarded the title Padma Vibhushan by the President of India.
It can be safely said that Dr. Bhatnagar laid the foundation of chemical engineering in India by carving a niche in the field of chemical sciences. Even in the times of political instability in Indian society during pre-independence, Dr. Shanti Swarup published his work in reputed international and national journals like Nature, the Faraday Society, Journal of Scientific and Industrial Research, and the Journal of Indian Chemical Society. From the fields of petroleum refining to war victory and sciences, from rubber chemistry to atomic magnetism, his research encompassed a wide range of topics. The focus of his work was on applied research, the work on which till date is being continued in areas of polymer sciences, petrol.
Thank you, Professor Saha. Moving right along for this evening's presentation, I would just like to quote what Dr. Bhatnagar once said pretty long time ago, but he mentioned that science has no future in India unless our agriculture and our industries are fully developed. We are trying and we are actually working on it. But he also said, more food and more health are dependent upon these factors. Scientific and industrial research thrives best when they're applied to material benefits. So with this, of course, all of us are scientists here, and we all been looking at atoms, chemistry, and galaxies to an extent, but has something to offer to every individual. And the most renowned ones are no exceptions to this, and their words provide us with bundles of motivations and inspirations, and also urges each one of us to live things or have things simpler in life. Well, with this note, I would now like to invite our director, Institute of Science, Banaras Hindu University, Professor A.K. Tripathi, to kindly introduce the eminence of our speakers for this afternoon. Sir.
Good afternoon. Respected teacher, Professor Rajiv Rawat, head of the departments, distinguished colleagues, researchers and students. I'm here to introduce Dr. Anjan Ray, but to very briefly introduce him, I'm a fan of him, and that's why he is here. I have been wanting to have him in Banaras us in the university. Because he's a person, I should not be saying these words in front of him. I see a glimpse of the persona of Dr. Shanti Swarup Bhatnagar in him. Because he is so gifted in very diverse things, literature, Indian history, and in chemistry, wide range of topics. And with a inclination to address the problems, problem solving. I think this is the main message of the life of Dr. Shanti Swarup Bhatnagar. Whatever life, whatever knowledge we have earned, that has to be applied for solving the problems of the society. As a director of the Indian Institute of Petroleum, he has to do it, and every director of the CSIR has to do it. But during 5 years of my stay in CSIR, I came several times in contact with him, and I find his personality so charming. Besides that, let me read out a few things about him. Dr. Anjan Ray received his doctorate in chemistry from the University of Pennsylvania under the guidance of a Nobel laureate, Professor Ellen McDermott. Thereafter, he worked for over 25 years in the chemicals and energy industries across a wide range of functions. He took up his current position as director, CSR, Indian Institute of Petroleum, Dehradun in November 2016. So, this was almost about 2.5 years later when I joined CSIR. During his tenure as director, IIP, he has also held some very important additional responsibilities of CSIR, such as head research, planning and business responsibilities of CSIR, head human resource development group. You would know it in a much better manner. The unit of CSIR which is responsible for giving different awards, including Shanti Swarup Bhatnagar Award. And he was also director of Central Building Research Institute, additional charge. Dr. Ray's professional interests span diverse fields of surfactants, lubricants, oleochemicals, cosmetics, pharmaceuticals, oil and gas, energy efficiency, biofuels, biotechnology, sustainable supply chains, and renewable energy policy. Is there anything left? He dreams of a future of India, a future India, where all fossil fuel and organic chemical imports would be displaced by products derived from domestic carbon atoms and sustainable energy sources, and decentralized pursuit of the nation's climate goals would be practiced widely under enabling policies. During his tenure, CSR IIP has exemplified pursuit of these objectives through India's first biojet fuel flight by SpiceJet in August 2017. This was the first time, a big news, that the SpiceJet plane flew, in which the biofuel made especially at IIP was used for the flight. That was the first experiment, a very successful experiment. Followed by over 65 hours of Indian Air Force projects. You know, Indian Air Force planes and the commercial planes, they are different. Their requirements are different. And ensuring that this fuel can be utilized by Indian Air Force, that was again a feat in itself. Leading to provisional certification for use in Indian Air Force aircraft of IIP brand of Sustainable Aviation Fuel, SAF, in November 2021. Recent agreements of Indian Institute of Petroleum with Engineers India Limited and Mangalore Refinery and Petrochemicals Limited have paved the way for India's first SAF, that is the Sustainable Aviation Fuel plant in Mangalore, which is expected to be commissioned in 2025. IIP's energy-saving PNG burner developed in partnership with the Petroleum Conservation Research Association in 2019, offers the promise of reducing approximately rupees 8,000 crores worth of annual natural gas imports to supply city gas distribution networks. This is expected to mitigate carbon footprint arising out of fugitive methane emissions in PNG-enabled households to the extent of 25%. Recently, Dr. Ray and his co-workers at IIP have disclosed a disruptive process capable of desulfurizing crude oil and select petroleum streams by up to 90% under atmospheric pressure without the use of hydrogen. When scaled up, this could significantly simplify complex refinery configurations, accelerate crude to chemical adoption, and decarbonize the fuels and petrochemicals value chain. Apart from his professional career in chemical technology, Dr. Ray has had an active interest in media. As I remember, he was staff in Doordarshan. He worked for Doordarshan for quite some time. Akashvani, sorry, Akashvani. And education, heritage, environmental conservation for about 4 decades. He is a recipient of Indian Federation of Green Energy Jury Choice Award for Outstanding Green Energy Activist in 2021 and has been felicitated by the Uttarakhand Ratna Shri Award in 2022. So, today, before the lecture of Dr. Anjan Ray, before the Professor Shanti Swarup Bhatnagar Memorial Lecture, we had scheduled the talk of inaugural message by DG CSIR, but as was said by Professor Madhurika Agrawal, that I was informed by her PA that she is in the Niti Aayog meeting and she will be joining as soon as she is free. So maybe after the lecture is over, hopefully she will be joining then and we will have an opportunity of hearing from her. So these two speakers today, they are the leaders in their respective fields. One, energy conservation. Dr. Kalai Salvi is a leader in the battery, and Dr. Anjan Ray in developing these kind of biofuels and many other strategies which will play important role in future in providing sustainability options to the country and the world. So with these words, I would like to invite Dr. Anjan Ray, and I will not talk about others since I have heard you before. I am more anxious to hear you.
Good afternoon, Professor Anil Tripathi, my dear learned distinguished friend, Professor Madhurika Agrawal, Dean of the Faculty of Sciences, distinguished professors, heads of department, teachers, scholars, students. It is a privilege to be here for the second Shanti Swarup Bhatnagar Memorial Lecture at BHU. Even though we've heard a lot about him, let me start with a shloka from the Guru Sutra. Professor Shanti Swarup Bhatnagar, as you heard, was a great scholar, not only of Hindi but also Urdu and Sanskrit. And he has been reputed to quote from the Guru Sutra more than once. So I will take it a little bit out of context and use the phrase Akhanda Mandalakaram vyaptayenam characharam tatpadam darshitam jenam tasmai Sri Guruve Namaha. Applying it to Dr. Bhatnagar, Guru jaise hote hain, Gurus like Dr. Bhatnagar are part of the whole, the infinite that pervade us. In everything that moves and everything that doesn't move, vyaptayenam characharam tatpadam darshitam jenam. उन्होंने जो मार्गदर्शन किया, the path that he laid for us, we salute such gurus. Even though you've heard him referred to, let us just see who he was, what were his facets, and why those facets remain relevant to us. Something like 75 plus years after independence, 80 plus years after he founded CSIR, what is relevant? This particular paper of his going back to 1938. Why was it important to know the diamagnetic susceptibilities of mercury in various stages of combination? The kind of things that he established were not only science for science's sake. Many people will not know that the work that he did in determining the magnetic susceptibility of metals and showing that the methodology for determining magnetic susceptibility required a precision measurement for which he and a colleague invented the device, that is used today for prospecting under the seabed. That is used today for beneficiating ores, because by knowing what is paramagnetic and diamagnetic and ferromagnetic in an ore mixture, you can design how that ore will be separated or beneficiated. Similarly, in the field that I worked in for many years, I worked in emulsion and colloid science, particularly when I was working in the cosmetic industry, but also later in the upstream oil drilling industry. The principles that he established way back in the 1940s have not been replaced by better principles yet. And often we do not recognize that. We talk about Newton and Jagdish Bose and many, we don't always talk about the academic contributions of Dr. Shanti Swarup Bhatnagar. Particularly interesting is the last one. I will tell you a short story with that. That in the year 1993, when I was just beginning to learn about cosmetic formulations, in the city of Delhi, in a room that was half the size of the stage with a 22-foot high ceiling, I was taken as a technical expert to meet one gentleman who was making a cream for Russia. He was exporting one cream for Russia. He had a turnover of a few lakhs, but he had this problem that he posed to our sales guys. They said, this is not something we are able to cope with. Please come understand what he's saying. So I went over. And this gentleman, he was sitting under his manufacturing unit because that's all the space he had. When the motor ran, he had to get up from his chair and move away in case something fell on him. That's how the plant ran. And he said, when I go to Russia and I offer a product, it works very well there. When I come to India with the same product, it turns liquid and it flows out of the bottle. I am not able to use the same package. More importantly, I see that I go to Russia, Scandinavia, people use sunscreens. There is no sunscreen in India. This is 1993. There was actually no sunscreen in India. And they use something called an SPF. Here, SPF, which is but it is something that they all claim. And when we tried to make a sunscreen here, the moment somebody sweated, the sunscreen got washed off with the sweat. How can I make a waterproof sunscreen? So this is an interesting question, because whatever is known of sunscreens is that most known sunscreens are oil solid. To maintain the sunscreen on the skin and to protect, use it to protect sunlight, I have to have the sunscreen absorbed in the UVB region. I have to have a certain minimum cutoff absorbance so that I reduce the amount of sun rays going to the skin. Otherwise, you get something called erythema, which is a sunburn. And then, mysteriously, I was flipping through stuff. There was no internet in 93. I was flipping through stuff in the library of the University of Bombay, and I came upon a paper by Dr. Shanti Swarup. And it said that if you alter, it's the last point there, if you have excess of adsorbed positive ions wetted by oil, you will generate an inverse emulsion where the water is inside, the oil is outside. It took us 3 weeks to give him a product. 3 weeks. It took him 6 weeks to launch it. You go to any shop today, any internet portal today, you will find Lotus herbals everywhere. Mr. Pasi passed away in 2007, but not because his innocuous question brought me to a Dr. Bhatnagar paper and showed me how fundamental science can make very good applied science. He used the fundamental science to invent in a wide range of industrial problems. His very famous one, and some of these were mentioned, but one of his most famous ones was his method for drilling of oil for the Atok Oil Company. And using the same principle, he actually used a cationic guar gum. Even today, cationic guar gums are used for the same application. 1955, and he's still using it. All these things were not related. They are all conceptually different, but they all related to only 3 things. A very deep understanding of thermodynamics, a very deep understanding of the properties of matter, and a willingness to try and fail. There is an essay by him, I could not locate it, I read it years ago, in which he said that the greatest failure of the Indian scientific establishment is that we do not encourage failure. This is one thing that I have learned personally in my career. I can safely say that there are many products out there which have come from my lab, my colleagues, many of which you don't even recognize. How many of you fill fuel at a petrol pump? Let's just quick show of hands. How many have been to a petrol pump recently? Do any of you notice or do any of you sense that the smell in a petrol pump is less than it was 10 years ago? Do any of you sense that a petrol pump smells less than it did 10 years ago? That's our work. We could show that there was a high incidence of cancer connected to benzene and petrol pump attendants, and we could use it to force changes in the way petrol pumps work. And that's why today none of you smell benzene. These are not things with which you publish. You don't get papers, you don't get credit, but somewhere you either save lives or you solve some human issue. And that in a sense is what Dr. Bhatnagar did. He constantly applied his learning to problems that appeared unrelated but used the same fundamental science. So when I talk about this topic of today and I talk about science and technology, you can't do technology without great science. So if somebody tells you that fundamental science is no use, please tell that person to go read Bhatnagar's essays, because without fundamental science there is no applied science. If somebody tells you what's the good of applied science, all the thrill is in fundamentals, I'll point out that the greatest progress in human history has come from applied science. The challenge is no one needs to do everything. All we need to learn to do is collaborate, but more importantly, share credit. If our culture were that we will look for people to plug the pieces we don't know how to do and we share credit, we get much faster results to the market. And I will tell you some anecdotal stories as we proceed on this little journey with the spirit of Dr. Bhatnagar, jinke padon mein hum chalte hain. So we talked about his policy shaping, his institution building, all of this is known. But look at what he first did. Before CSR was formed, it was the Board of Scientific and Industrial Research. And look at the number of products he developed in 2 years. How did a board coming out of nowhere in a non-independent India with you know how much funding in those days? A total of just 5 lakh rupees for the entire country's BSIR was able to produce all of this. Why? Because you encourage problem solving and you encourage failure. You tried, you failed, you learned, you tried again, you got better, you asked people, when you asked people you got new insights, and then you were able to succeed. Another thing that very interesting, even more than him, was Dr. Atmaram, one of his students, who was eventually director of CGCRI. Dr. Atmaram once said a very interesting thing. He said that one of the learnings that he got was that an imperfect product may still be good enough. So if you try, you don't succeed completely, put the imperfect product in the market or get it started, you will get enough feedback and enough ideas to improve on it. So another this thing, you don't need to keep working till perfection. Yeah? Luckily, very luckily, the consuming public is less difficult than a difficult reviewer in a journal. Yeah? The consuming public will take it. He may say 3 things that you don't like, but eventually he'll give you tips. But even if you buy a poor tomato from a ठेला वाला and you give him feedback the next day, he will say, okay, yes, आपको हमें गंदा टमाटो नहीं बेचना है. I'll keep that for somebody else or for the tomato sauce maker. I obviously did. There is a saying that it is human to make mistakes, but to really cause complexity, you need technology. We just saw an example. But let's come to the bit we talked about, his artist at heart, the poems he wrote for his wife, the Urdu story. He had it in his genes. When we talk about, there are people here studying genetics. In his genes, he is a descendant from his mother's side of Munshi Hargopal Sekandrabadi. That is the letter that Mirza Ghalib wrote to Munshi Hargopal Sekandrabadi, conferring upon him the title of Mirza, somebody he considered as equal. And Bhatnagar Sahib is descended from him. No surprise that he wrote poetry, he was a competent actor, he performed his own one-act play on stage, so he acted it too, he didn't just write it. And the principal of Dayal Singh College extolled that in a letter in 1911. Let me compare him with somebody else. Some of you may recognize the picture, we can run a quick query on this, but this was a gentleman born in Persia, almost 1,000 years before Dr. Bhatnagar. And he was able to document that the Earth's period was 365.242 days, almost accurate to the level that NPL determines today using legal metrology. He was able to develop conic equations, and this is from one of his books. He was a philosopher who wrote about the meaning of life. Does anybody know his name? Anybody willing to guess from the photo? Actually, Persia, bada hint. नहीं? आप लोगों ने उमर खयाम का नाम सुना होगा? Umar Khayyam. We know him as a poet. But today, when you do conic sections, when you draw a hyperbola, when you define an epicycloid, the fundamental will give Umar Khayyam. Somehow, because he was from the East, when West talked about Euclid, he was lost in the pages of history in the West. But he is, even today, one of the most fundamental contributors to science and astronomy. But we know him as a poet. So where does this take us? This takes us to the very basic principle today that the way most of us, Professor Madhulika, Professor Tripathi, Professor MS Singh, most of the people here who are senior today, we learned our science, and in fact we learned our non-science also in a very different way. We look to our teachers for knowledge, but the knowledge mostly came packaged as information, and the teacher in the classroom helped convert that information to something we could use practically. Today information is democratic. You can get it off the net. What you don't know when you get it off the net is what's correct and what's wrong. So one of my own students, I had the privilege of teaching journalism for 4 years, so one of my students in journalism is now a professor in Northumbria, Santosh Vijay Kumar, and he teaches a paper on media disinformation. And he was an authority in England during the COVID misinformation pandemic. So misinformation was a bigger pandemic than the pandemic itself in some ways. But we go to this, and I take 3 Nobel laureates, and let's just look at their perspective. We start with Tagore in 1913 in Gitanjali from his famous poem, Chitto Jatha Ghoshan, where the mind is without fear. He uses this phrase, where the world has not been broken up into fragments by narrow domestic walls. You can interpret it as you wish. But even the thinking of my department and your department is a narrow domestic wall. anything that divides, that moves away from that shloka that I used, right? Akhanda Mandalakaram, the undivided universe. Anything that moves away from that is a way to reduce the universe to simpler and perhaps less meaningful fragments. Below that, Linus Pauling, one of my inspirations for generations, a Nobel laureate in both chemistry and peace. One of the only man to get a Nobel Prize in two different things, right? And when he talks about the general principle of science, he says it's not a game when you try to beat your opponent, do harm. He underscores science with morality, justice, humanitarianism. You can't get that from science. You can get that from technology. So what he is really saying is apply science wisely, apply science well, and apply science for doing good. And then comes my own PhD guy, Professor McDermott, who would walk into the lab occasionally and he would say to me, I actually have his voice still recorded here on my phone. He would say to me, Anjan, what are you doing? And I would say very happily, sir, I'm doing this. He'd say, oh, and what is your chance of success in this experiment? And like most scholars here, we would say very proudly, 100%, sir. And then his eyes would stop. Throw it away. You're wasting grant money. You're wasting your intelligence. If you're 100% sure, why do it? Then he would add, what degree are you getting? I would say, PhD. He would say, what subject? I would say, chemistry. He would get to this. Wrong. PhD has no chemistry in it, it just says PhD, doctorate in philosophy. It is the narrowness of the human mind that will divide knowledge into subjects. You are supposed to go out and get whatever you need to solve the problem at hand. You can't say I will only do chemistry. As it turned out, I spent most of my life practicing as a chemical engineer. These days I practice more as a biotechnologist, trying to understand why lychee trees grow under lychee trees. 10 feet away from a lychee tree, if I drop a lychee seed, a tree will sprout. Under the lychee tree, a tree won't sprout. So is there a rhizosphere signaling something to its microbiome in the soil? To degrade that is a research problem, and today I find that there are unusual amylases in the microbiome under the lychee tree which are not there 10 feet away. So question is, what's the problem at hand? And can we use that to actually address some of the core issues? Address some of the core issues of progress. This is progress, right? These are all the metrics we talk about: foreign investment, GDP, motor vehicles. They have all grown, but look at what else has grown with it. So actually, as a human race, we have proceeded on a parallel track of construction and destruction. And that parallel track looks like this. All the species that Professor Tripathi and Professor Matulika and I would have seen in our childhood, 60% of the vertebrates are actually gone. Man is the only species that actively takes actions that displaces and causes extinction of other species. Most of the species work within their ecosystem, and when we use the word pristine forest, pristine beach, pristine mountains, we mean one where man has not gone and dumped an additional atom of waste. That is what pristine is. So what do we actually do? What we actually do is re-examine what is sustainable. Sustainability, BJ's definition often is leave enough for the next generation. But on the other hand, when I open my newspaper, whether it's in Delhi or in Varanasi, it's full of advertisements. What are they telling me to do? Go out and buy. Buy what? Things that I probably don't need, but maybe I want. Now here's the interesting climate change correlation. What's a machine? A machine is something that takes work, takes energy and gives me work. That's what a machine is. All of us know this from class 7. No machine gives me 100% work compared to the energy I put in. All non-fossil energy contributes to climate change. Therefore, every machine, every time it operates, if it uses non-fossil energy, contributes to climate change. Sorry, if it uses fossil energy, contributes to climate change. Even if it uses non-fossil energy, it might contribute to climate change, because not all non-fossil energy is carbon. Therefore, if I overconsume, even if I buy a shirt that I did not need, somewhere a machine has run for me for part of the time. If I send a good morning message or I do a Google search that I do not need, somewhere I have consumed power in a data center. In fact, one Google search on an average is a light, 5-watt light bulb blowing for 1 second. Think of how many Google searches I have. So, this is not about some government, about some policy, not even about scientists, it's about us, it's about human behavior. What can we do to build awareness of human behavior and make it widespread so that we are doing the right things which are adequate for us but are benefiting the planet? When we talk about leaving the earth sustainable, it's not only for our children, it's for the children of all species. And there is a song by John Denver called I Want to Live. Highly recommended if you'd like to hear it. So this led us to the UN Development Agenda. And in the UN Development Agenda around 2000, there was this big discussion of what should be the goals for the new millennium. This was incidentally the year in which Alan McDermott won the Nobel Prize. So it's a watershed year in my life in a sense. But all the things they did with the 8 Millennium Development Goals, which sounded very ambitious back then, by 2015 it was clear that that was not enough at all. And what they found in 2015 was that the Gini coefficient, which is nothing but a Lorentz curve, adding A by A plus B. So in this little curve of mine, the 100% point represents if 1% had all the wealth in the country and everybody else had zero. You know, for example, I think there is a thing called Harry Potter, he who shall not be named. Suppose that he who shall not be named owned all the ports in India and all the power stations in India, etc. Nobody else owned anything. That would be 100, 0, Gini coefficient would be 1. And if everybody owned exactly the same thing, Gini coefficient would be 0. As it turns out, 0.35 is roughly the Gini coefficient cutoff for the world average. India is at 0.35. Anything higher is not good, and every country that was colonized has higher than 0.35. Every country that was a colonizer is lower than 0.3. What does it tell you? That misdistribution of resources eventually led to misdistribution of income and wealth. And that led to the Sustainable Development Goals. I will not actually spend time on all these 17, but DGCSR is at Niti Aayog, which is tracking this on a daily basis. It is 169 metrics. Again, for any scientist who wants to look at applied research, or anybody who is not in science but wants to look at the socio-economic impact of science, or look at the anthropological aspects of science, this is a very good place to start. The Niti Aayog dashboard of the SDGs and its 169 metrics. And from the SDGs, we get these two rules. One of the greatest thinkers of the late 20th century, Ismail Serageldin, is a librarian in Egypt. So he's not a scientist, so you won't read him in any of the journals, so you probably don't know about him. But he encapsulated two simple things. One is, don't take out more than the earth can give you. And the second is, don't dump more than the earth can absorb. That's what the two rules say. If we measured all our actions in these lines, we would actually leave the earth a better place already. But we have to measure it for everything. In fact, there is a very nice little app produced by a young teenager. It's called Cool Our Planet. So if you put that app on your phone and you just start behaving accordingly, many things quickly change. Or cool the globe, sir. Anyway, so now we are actually dealing with all these issues. We're dealing with climate change. We're trying to reduce the impact that it will have, or trying to reduce the rate at which it will happen. We're trying to make ourselves better equipped to deal with the change when it happens. And we're trying to actually bounce back if the change is catastrophic. But all of these are already consequence of what we have done. So if we continue to do what we have done, this is going to get harder and harder. It's not going to get easier and easier. And the most graphic example of that is this overconsumption. This graph shows you from 1900 to 2005, the ratio of this parameter in 2015 to 1900. In a 115 years, if my population is treated as level, then we have overconsumed everything relative to population except food. Food is the only thing that has gone down. And do you know why? Because today, no son of a farmer wants to be a farmer. In this hall, I know at least one son of a farmer from Jaunpur who is doing his PhD over here. Right? This is a reality. And look at particularly the really big problem is not even in water, it's probably not even in fossil fuels. Dr. Madhulika said I'm from the oil and gas industry, so you know whatever. But it is actually from the ores and from non-metallic minerals. It's from silicon. It is actually one of the worst possible culprits is ceramics. 2% of China's carbon footprint comes from just ceramics and glass. 2%. Because ceramics and glass are heat intensive, and after that they are also material intensive. Those materials are quarrying intensive. So whatever you're doing, so Dr. Atmaram must be wherever he may be, he must be thinking, I did this, but what's happening in the world with it? Let us use this knowledge of overconsumption as scientists to do a little bit of atom count. This is a concept that I started exploring in about 2017. And I said, instead of dealing with molecules, materials, supply chains, why don't we just count the number of atoms of everything I take and everything I give out? So I just look at the atoms of India and carbon atoms. We've all heard right from our early days that India is a net importer of petroleum, right? The question is why? I'm importing 350 or 330 million tons of atoms per year. Now it used to be 350, but after ethanol blending it has already dropped a little bit. But in our own country, so we are importing all this, but in our own country, we are throwing away more than 460 million tons every year. If I just knew how to use the carbon atoms I throw, I could get up and tell the world, I do not need your petroleum. I do not need your natural gas. Why are we not doing more research to repurpose our carbon atoms? Because it doesn't get published in the highest rated journals, right? There's no impact factor if you recycle a carbon atom. It's probably known. But if you're able to do it, look at the service to the planet. So let's see how we would do it. I'm just taking carbon atoms as an example. We can do this for silicon, lithium, aluminum, you name it. We can even do it for hydrogen. We're talking green hydrogen, but most people are forgetting that when I produce 2 kilos of green hydrogen, I will produce 16 kilos of green oxygen. Nobody is talking about building oxidation chemistry plants next to green hydrogen plants. I would say the chemistry department of BHU could be the first in the country to have molecular oxygen chemistry where your plants will sit right next to the green hydrogen plants and decarbonize the world. People haven't even thought of this yet. So I'm just giving an idea. Because somewhere, if you're letting the oxygen go, somewhere else in the world, somebody is using fossil energy to produce oxygen and then use it for chemistry. Let's have a look at this simple mathematics. It was mentioned by Professor Tripathi about our jet fuel process. We take carbon atoms from lipids. These lipids could come from trees, they could come from used cooking oil, they can come from animal fat, they can come from sewage, they can come from the coffee that we have discarded after drinking coffee. Everything has lipids in it. And those lipids I am able to convert to a biojet fuel. That biojet fuel is actually able to fly planes. That fuel is now being certified internationally, so it can fly all planes, not only Indian Air Force planes. But at least the first time it flew, I had the courage to get on the plane. So the plane flew, I was on it. That is sufficient confidence that the plane would not fall off the skies. And the funny part is it's not technically very difficult. It really isn't. It is, it needs science. It needs rigorous science. But once you have the science ready, the technology evolves. It finds its own pathway. This is another one. Most of you have heard of biodiesel. Today I am able to make biodiesel on this tabletop using basic thermodynamics. I will add everything, we will go for a cup of tea, we will come back, the biodiesel will be there. There is nothing done except adding things at room temperature. Why? because delta G equals delta H minus T delta S. Biodiesel manufacturing is a transesterification. I add an alcohol and an ester, I get an alcohol and ester. So my delta H is what? It's 0. I've broken the same number of and same kind of bonds broken and made. Delta H is roughly 0. Conventionally, people have driven the reaction by raising P so that I can get my delta G negative. But we have figured out how to raise delta S instead. Therefore, at room temperature, I simply use the principles of Dr. Bhatnagar of emulsion science, and I raise delta S, and the reaction proceeds at room temperature, and we come back and we take it out. We are able to produce it at 150 liter per day scale using cooking oil from the canteens in Raipur, Chhattisgarh. The plant is run by the lady who used to make tea because you don't need skilled labor now. It doesn't need electricity. And we are planning to put 50,000 of these units across India in 10 years. And those 50,000 units will be the equivalent of a Mathura refinery. Okay? It would need no subsidies, people would make it themselves, and the product will be able to run a tractor or a diesel genset. The same thing with biomethane. This is a lot of research going on across the country. There is a move. Remember I told you we import natural gas. Why should we? We can produce 12 times the amount of natural gas we import by just the biogas potential in our country, whether it's the gaushalas or whether it's the fruit and vegetable markets or whether it is the sewage. We can produce more biogas than we import, and we can convert it to pipeline quality biomethane, and we are doing it. We were doing it in Pune inside the municipal dump. I have moved the same plant to Rudrapur, and the government is planning to fund 5,000 of these plants. So our technology, which is now commercially in the market, we're hoping out of 5,000 we'll do at least a couple of hundred. But this is not rocket science. So again, no publications. What we do get publications from though, is we get patents, and we get publications from applying those patents to new areas. For example, with the biomethane chemistry, I'm able to do new science because now I have compositions of CH4 and CO2 that I can do. So I can actually fix my carbon dioxide methane ratio, and I can dry reform it with a catalyst. Methane is a worse greenhouse gas than CO2, but reforming them together, I take hydrogen from one, oxygen from the other, I make CO2, hydrogen and water, and from that I'm able to make fuel. So we will be putting up, using this concept, the country's first deuterated methanol plant sometime in the next year or so. We import all our demethanol, but we will now be able to make demethanol. Similarly, waste plastics. I was just driving around from Sarnath up to Ramnagar Bridge today. Lots of waste plastic around the roadside in Varanasi. In Dehradun today, you will not find much waste plastic. We have now put 20 plastic banks across the city. Schools, colleges, institutes, cantonments, hospitals, they all have waste plastic banks. We would encourage you to have one here. Collect your waste plastic. After that, you can simply process it. At the least, you can granulate it because it has not gone to the kachra dump. So it's easier to clean and process. And in our campus, we built this beautiful 5-story building. It runs round the clock. We run it with fresh BTechs and ITI students. And it produces about 650 liters of diesel from 1 ton of waste plastic every day. And then we use it in our jet sets and our buses. So each of these things, now this is, by the way, this doesn't help your carbon footprint because waste plastic already has fossil footprint, but it does help your environment. This is another one, just like we talk about, burning agricultural waste in Delhi, the annual smog and this, that. It's also true in villages and smaller towns, this problem is there. So instead of trying to bring the waste somewhere and solve it, we built a machine. This is in partnership with Aston University, UK. This machine actually goes to the field, and over there itself it makes biochar plus a bio oil that we use then for brick making, and it produces gas which runs a genset that runs the machine itself. So we have the first unit operational at Nabarangpur in Odisha. We are again planning several dozen of these units over the next couple of years. But all of these examples I'm giving you have very deep science. The waste plastic process, because there are many plastic pyrolysis technologies available, but they produce a fuel oil. Ours is the only one in the world that makes Euro 6 diesel directly from plastic. But that's required 10 years of research. So has the jet fuel. Now, these are all examples of how I find domestic carbon to replace my carbon imports. Why can't I reduce my carbon imports? That would be even nicer. We can reduce it pretty easily with one example. This is a burner, very simple idea, that people are switching over from LPG to piped natural gas in many parts of India. However, LPG has a vapor density of 22. It's heavier than air, which has a vapor density of 14.7. And piped natural gas is methane, it has a vapor density of 8. Using basic computational fluid dynamics, I can show that if a burner designed for LPG, that burner cannot, and I repeat cannot, burn PNG efficiently. So if I change an LPG burner with minor adjustments and put it on PNG duty, I'm losing 25% of my gas. Gas is imported. So on existing connections alone, I could save 2,200 crores of foreign exchange. And the connections are growing, so we can save much more. Very simple, very, very simple intervention. Again, it won't get us publications, but it gets us a big blow towards mitigating climate change. Similarly, one of the things we hear often is that renewable energy is expensive because it needs batteries. Any of you heard this statement? That renewable energy, we need batteries to, you don't. You don't need batteries at all. We are running it on our campus, we have a 15 kilowatt unit, there's no batteries running it. What we do is we use the power of smart controllers, not even AI, just a smart controller. We have a solar wind hybrid turbine built by our colleagues in National Aerospace Lab. On top of that, we put a biofuel or a biogas genset, and I've shown you how to make biofuel biogas at home. And you couple it with the genset. Whenever I don't have solar or wind, the bio kicks in. So it's, if not net zero, it's near zero, and it's all renewable. And these systems are now charging our e-vehicles on campus, except that we don't buy any e-vehicles on campus. So where do I get my e-vehicles from? Some of you may have noticed that there is these rules saying that old vehicles have to be scrapped, right? What will we have to do? We'll have to take the old vehicle, send it to a scrapyard, manually or mechanically dismantle it, then I'll have to put 1,000+ degrees temperature to melt the iron and reuse it. Why? Why can I not instead take my car and simply turn it into an EV? Take out the engine, make some adjustments in my suspension, balance my weight, and put a little electric motor with a battery at the back. This is what I drive in my campus now. We are planning to train 10,000 people across the country to do these retrofits. We've just signed an MOU with the government of Manipur. Manipur is India's one of the worst carbon footprint states because it gets all its fuel from Assam 1,000 kilometers away on a single highway where the vehicle speed is very low, so you're burning fuel to deliver fuel. Instead, Manipur simply becomes the retrofit capital of India. So this would be true not only of vehicles, of cars. It would be even better for rickshaws, three-wheelers, tempos, all the things that are particularly bad from a climate change and emission standpoint. And you could apply the principle generally, but you have to do the research specifically. For every type of vehicle, you'll have to redo the research, but the template will be the same. Finally, our latest innovation, this is already launched, we are doing trials now. Do we really need cold storage? We hear that 40% of India's harvest is spoiled after it is produced because it doesn't get to the market in time. One thing is we built an app called Kisan Sabha. I have 9 lakh farmers on the app, which helps them get their product to market faster. But more importantly, just as I showed you in the example of the biodiesel case where I can make it at room temperature, I asked the question, why do I need cold storage at all? Why do I need it? Does anybody know why I need cold storage for food? Why do I need it? Anybody please suggest? So you're talking, everybody, we need cold storage, we have fridges at home, this, that. Why do I need cold storage for the agricultural value chain? microorganisms. What kind? Aerobic or anaerobic? Mostly anaerobic. Somebody said mostly aerobic back there. Depending on the conditions, it could be anaerobic or aerobic. Correct? So it needs a substrate and it needs an operating temperature. By lowering the temperature in cold storage, I reduce the rate of enzyme activity by roughly 50% for every 10-degree drop. But food is also spoiled by rodents. Correct? They are not microbes, pests. Suppose I simply raise my carbon dioxide concentration in a food storage chamber, even under ambient conditions, from 400 ppm normal to 1200 ppm. What happens to my rate of decay? In case of aerobic microbes, it drops very sharply. In case of rodents, it goes to zero because rodents don't come after your CO2 level goes over 600. Why do I need to lower the temperature? I do. So by simply having dry ice, which I make in this little machine, 5,000 rupee machine, again run without power, with unskilled labor, I can make 5 to 6 kgs of dry ice per cylinder. The cost of preserving a Tata 407 truck, which today if I had to put a cold storage for a Tata 407 truck and drive it, let us say from Varanasi to, let's say, Kanpur, if I had to drive that truck, I would require something like 7,000 rupees of additional cost. With this, I am able to do it for 380 rupees of additional cost for the same result, or more or less the same result. So just in the closing minutes of my talk, I'd like to point out that just because things are done a certain way doesn't mean that there is no other scientifically viable alternative answer. If we get back to first principles, and if you understand that sustainability is basically about conserving resources and about questioning the way we use resources, we might find lots of new ways of aligning science and technology to preserving our planet. We live in a nice ecosystem and very privileged. I tell people that, पुराने जन्म में बहुत पुण्य किए होंगे. So I live in a country like India with visionaries like Dr. S. Bhatnagar, who have given us a template. In that template, we have seen that while the future of the planet is threatened, we have a path to decarbonization and resource efficiency. Just use our atoms wisely. We don't have to think of economies of scale. If I can do things locally, we actually do better because we're not having to spend faith to move energy or goods. And finally, I invite all of you to come and see a sustainable ecosystem like the one we have. We finished our bird count yesterday. 2023, we are up from 212 to 217. We were at 64 in 2017. Our butterfly count is 100 plus. That's the road I walk every day. Thank you for your time.
Thank you so much, Dr. Ray. This was such an enlightening presentation. In fact, you get most of us lingering to each of your words. So with this, I would now request our audience if they have any questions to our speaker. Please. Anyone?
It's such a wonderful talk to hear. So mesmerizing to say. But the problem is not that people don't develop technologies, but how to bring it to a scale that it could be used at the level it needs to be done. I'm sure you agree with me.
Yes, sir.
So how to bring it to that level? That's what perhaps
Sir, I think
the problem is.
you used a very important phrase, needs to be done. I think the first challenge is to disconnect our approach from doing the science we want to do to doing the technology that needs to be done. So first is actually identification of the technological need. Because if we use our science to simply produce a product, that product may or may not meet a critical need. But yes, if we have a product and we believe it is evidence-based and meets a critical need, you'd be surprised at how many people are willing to fund it. One of my favorite shows, I picked up the habit from my daughter, is a thing called Shark Tank. And when you look at Shark Tank, Professor Tripathi will be very happy because Nirmalya, which is based on using temple flowers for fragrance cones, has just got Shark Tank funding last week. I don't know if you knew that.
Yeah, it's my favorite show too. I also keep seeing it.
Yeah.
And I
So,
like it. Yes.
so if you look at Shark Tank, none of them pitch a product that they have imagined. They all pitch a product that they have identified as an unmet gap in the market. And I think that is one of the key. So I always say that please don't discourage scientists from doing their science, but please refrain from pretending that the science is going to go to market. Instead, tie up with somebody who is good at going to market and bring your alignment such that the scientist is able to give the product to the technologist. Those partnerships go very far. I can personally say that during the COVID pandemic, we were called upon to address the oxygen crisis, and there was a very big national effort. So being petroleum people, we know how to get rid of oxygen. So we said, can I use the same principle to purify the oxygen I'm getting rid of? And we could. So we were asked on 14th April 2021 to put some oxygen plants in the market. On 15th October 2021, we had a 108 operating oxygen plants, 1 ton each, 100 patients each. 11,000 patients are hooked up to our oxygen plants, and I can run them from my laptop each night. So that is because, not because we invented it. We only knew how to do the oxygen. But we partnered with everybody we could find who could do the rest in many cases. So these are the little things. The example I gave you of the petrol pump. We partnered with all the oil companies, with the pollution control board. We didn't want the credit. We just wanted people safer. So I think that's it. If we want to take our product to market, if we want to make it happen, engage early with those who know what the market is. And be very, very willing to share the credit of the spoils. बहुत आसानी से काम करें. Personal experience.
Anyone else?
Thanks for the talk. It's very inspiring, obviously. And we're mesmerized that as Swarup said. We also see cycling and other things. We also have this idea that we should change another thing. But it's a very debatable issue almost all the time. That it's multiple effects. Policymakers also become it. I know your DCCS are probably also trying to do that. And it's the same thing. It's nothing new probably I'm taking. And also we need to have channels either in university or somewhere that it should be injected regularly. Just saying these things and hearing you only one, probably we just shake a little bit, but we're not channelized almost all the time. It's happening. So what is your idea in that how CSI and others can come into the effect that we should be heavily impacted and then get effective?
So I think whether it's CSIR or IITs or ISERs or universities generally, the talent pool already exists, right? I think the policy already exists. In fact, the NEP is kind of trying to nudge you in that direction, trying to move you to holistic knowledge. Because very often, if you have a product and the economics is not right, it won't work. If the economics is right and you have the product, but the social framework is not right, it might not work. If the economics and social framework is right, but at the end of the day there is environmental impact, sooner or later somebody will point a finger. So I think everyone who is eventually interested in taking a solution to market must recognize that if today's situation is X and I want to go to Z, the delta between Z and X is defined by 4 things. The first is performance. Does Z work as well as X? The second is scale. Can I get as much of Z as I can get X? Is it available to me? No, it may be brilliant, but if I can't get it, what's the point? Third is cost. Is it affordable? And that cost may be with a caveat, like solar energy was not affordable, today it is. Mobile phone telephony was not affordable, today it is. So you have to invest, somebody has to prime that pump, usually the government or an investor will do it. And the fourth is sustainability, all the parameters I gave. But if you are able to filter these 4 points, before you start saying I have a product or I have a technology, so if you're self-critical, I think we get better results. And much of Dr. Bhatnagar's writings, Dr. Atmaram's writings, Dr. Mashalkar's writings have shown that you have to be self-critical and you have to have a proper framework for evaluating these. An easy framework is the assured matrix of Dr. Mashalkar. Again, for those who haven't seen it, highly recommended to look at it and tick boxes. And it will tell you, like I said, you might still have an imperfect product, but at least you might be able to go ahead and offer it to somebody. All right? Thanks.
Anyone else?
Well, the way you have now lived several years in Dehradun, find some solution to forest fires, which are reducing the forest cover of the whole world?
So I'm very happy you asked the question. There is the CM of Uttarakhand is going to Champawat on the 24th. We have adopted a block in Champawat which is having forest fires, and in partnership with your own institute, CIMAC, we are trying to recover pine needles. Anything that catches fire is a fuel, so we'll recover the volatiles first, and the rest of the pine needles are being used as briquettes in a low-cost chula, where we are teaching lohars to make the chula themselves for less than 500 rupees a piece. With those pine needles, it's a very low smoke chula, so indoor air quality improves. Further, using our carbon dioxide solution, we are testing perimeter fire containment, because if we drop from a drone these CO2 blocks, we can't extinguish the fire, but we can control the perimeter, so we are trying some experiments there.
Because I was tempted to ask this question. You said that you can remove oxygen. So you see California fires, forest fires. In Uttarakhand, every time summer you go there are fires. Is there a way to take away oxygen to prevent, once the fire has started, is it possible to stop it?
So that's what the CO2 will do. It will not be able to stop it because the rate at which a fire burns in a forest is very fast. The kinetics is unfavorable. I can't drop CO2 at that pace. But I can drop CO2 along the perimeter so I can contain the fire from spreading.
Sir, I would like to ask a question.
Yes, yes, sir.
This is about the barriers. You said that due to barriers of plastics,
Yes.
pyroplastic.
We convert it into diesel, actually, into Euro 6 diesel directly.
Right, so that conversion, does it also yield some sort of a waste product in this process?
So most plastics, compounded plastics, contain between 1 to 3% of fillers. That comes out as an ash. Also it has byproduct. It has a little bit of naphtha as a byproduct. And it has LPG. But because it's a pyrolysis process, we start the process with raw LPG, and then we use the LPG as it starts coming off the plant to run the plant.
Are there any carbon soot in this process? I mean,
There is carbon soot. Another very good question. Anytime I have a carbon-carbon bond, I will have soot. So all fuels have soot. But LPG has less soot than diesel or naphtha. So when I'm burning LPG inside my process, it's much less than firing fuel oil or firing coal.
thank you so much, sir. Thank you. If no question, then maybe I think we can thank the speaker again for this wonderful presentation. There are three principal means of acquiring knowledge: observation of nature, reflection, and experimentation. Observation collects facts, reflection combines them, and experimentation verifies the results of those combinations. We all have got all these three flavors while listening to Dr. Ray in this beautiful and enriching presentation. So with this, I would now request our director, sir, our dean ma'am, to please felicitate our speaker of the afternoon, Dr. Ray, please, for which I would like to invite all three of you onto the dais. Thank you so much, sir. Thank you, ma'am. Gratitude is the fairest blossom which springs from the soul. As we have come to the closure of this event, I would now like to invite Professor S.M. Singh, sir, to kindly offer the vote of thanks, please.
Evening, everybody present in this hall. Am I audible? Professor Anjan Ray, Dr. Anjan Ray, Professor Bati, Professor Madhulika Agarwal, Professor Rajiv Raman, all other distinguished senior teachers, colleagues, and dear students. I have the proud privilege of presenting a vote of thanks on my own behalf and on behalf of the Institute. Thank you very much, Professor Tripathi, for giving me this honor. First of all, Professor Anjan Ray, I had heard great things about you from Professor Tripathi, that you're a great orator. But then I was apprehensive that you're a petroleum man, God knows what you're going to speak. I am of life sciences, how will I propose a vote of thanks? I brought a piece of paper with me that probably I like to write down few things when you speak. But then all things, apprehensions that I had in my mind went away with the magic that you played. It was great. And how foundations in science are important, how their applications are important, and how we can conserve our planet and make it more inhabitable for everybody, birds to butterflies to human beings. Thank you very much, sir, for great lecture that you have given. That will be inspiration to many of our youngsters, also to our teachers who are doing research. Thanks again for accepting the invitation to come to BHU and giving this great lecture. So thank you very much. Thank you, Professor Tripathi, for being the source of inspiration, for being the force also behind everything. Bhatnagar Memorial Award, Memorial Lecture being, because Shanti Swarup Award is always involved in great lecture. So, Memorial Lecture being held, you have been the force behind it. Thank you very much, sir. And keep your inspirations always for all of us so that we are having our kinetic energy running all the time. Professor Madhulika ji, I don't know how to thank you. Your epitome of human empowerment. I think she's our first female dean. I don't know that there was. Chandana Haldar, she was director also. But thank you very much, madam, for all the inspiration, all the energy that you provide to everybody, and being there on all occasions to help us as an inspiration for all of us. Professor Maya Shankar Singh ji, very nice person. Speak of your contributions to our institute. Keep them going again, always for all of us. I am highly grateful to all the organizing committee members for Shanti Swarup Bhatnagar Memorial Lecture, particularly Professor J.K. Roy, Professor Chelapati Roy, Chelapati, I call it for Rao, very close to each other. I should have written few things there. And then, thank you very much. Very good conducting of the program. And thank you to all in the audience for being here. In the beginning, you have given us heartbeats. That probably if you are not there, then we feel highly insulted today. Such a great and finally, for leaving from here, Dr. Anjan Ray's lecture, if he gives in front of our great giants of petroleum industry, they will get nightmares one day because they make things so cheap for common people that their industries will tremble. I don't know about that. Probably you know that. How much pressure, political pressure you might feel. Now I think I will request all in the audience to kindly stand up for
जनगण मन अधिनायक जय है, भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा, द्राविड़ उत्कल गंगा। हिमाचल यमुना गंगा उच्छल जलधि तरंगा। तब शुभ नामे जागे, तब शुभ आशीष मांगे। गाये तब जय गाथा, जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय है, जय है, जय है, जय 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 है।
We have light refreshment outside, so I would request that please join us. Thank you.
Thank you for choosing. Are you recording this lecture for your personal purpose or for uploading it somewhere? Is it on YouTube?
There was light.